Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome into the program. I hope that you've been doing well and you are ready for today's show because, hey, we have the one, the only Mr. Ralph Bond. He'll be joining us here in just a moment as we talk, well, all things science and tech trends and what that could be. Well, you're going to find out there are a number of stories that are, we didn't really design them, but Ralph goes out and finds them, and they are stories that you probably haven't heard of and you definitely want to hear of. So that's where Ralph comes in. He joins us every single Friday to look through the news of the week and decide, this could really use your attention. And these stories are fun, but they are also signs of where technology and science is heading. It's a very fun segment. And I can't think of a better way to kind of wrap up a week than to do a segment like this. So with that being said, computeramerica.com, that's where you'll find everything, including past shows, future shows, show notes, articles, blood, sweat, tears. Ladies and gentlemen, you will find it all at Computer America. And if you refresh hourly, it's changing every hour. We've been working on it, and it's Ralph says it looks good, so we're going to take his word for it. And the website's looking good. You can, of course, find places to listen to the podcast. You can find the past show notes. You have a whole section at the top across the navigation bar. The third one, I believe, is Ralph Bond. If you go there, you'll find his latest video show, as well as past show notes there right underneath. So if you miss a show or you want to go back and just relive the glory that was previous Ralph Bond segments, hey, we got you covered. All right there at computeramerica.com. Also find us on social media links everywhere. And let's go ahead and bring Ralph on and just have fun with our Friday segment. So once again, he is our science and tech trends correspondent. Very happy to have him here. And Ralph, welcome back onto the program. How you been?
It's great. It's great to be back. And I want to emphasize again, as you just alluded to, the website is really developing great. I love it. I love the animations that are added to the background too, by the way. That's a kick. And friends, it's so important to come out to computeramerica.com, not only to see the growth and the development of the new website, but also to get today's show notes, because we're going to have links to the articles that we're going to highlight and so forth. But with that said, I want to just sort of set the stage for somebody who might be new to the show today. What Ben and I do each Friday is highlight 4 recent articles that show us key trends and developments in all kinds of things: artificial intelligence, robotics, medical technology, sustainable energy technology, transportation advances, agricultural technology, space research, physics, you name it. But here's the deal, folks. Most important of all, we're going to give you an oasis of positive news thanks to the world of science and technology.
Absolutely. I couldn't have said it better myself. And ladies and gentlemen, if you're watching the video portion, appreciate that. We're going to have the show notes there. We're going to be showing pictures and video and whatnot. But for everyone out there simply listening to the podcast, we're going to try to keep it simple for you. So with that being said, you can see up there on the screen, nice banners. Let's go ahead. And Ralph, why don't we just start with story number 1 and see where it goes? I'm betting story number 2, but we'll see.
Okay. Well, the first one is really kind of interesting. Comes from Hydrogen Fuel News. Talk about a specific focus for an outlet. Hydrogen Fuel News is the source. The headline: Liquid hydrogen storage breakthrough puts zero-emission aviation within reach. Wow. And the subhead is: Student team pulls off first flight test of liquid hydrogen-powered electric aircraft. And you might be saying to yourself, well, Ralph, you and Ben, and I've seen about hydrogen being possible source of energy for flight, for aircraft, but so what? Well, you're going to find out why the so what here. It has to do with liquid hydrogen. So let's get into the story. Mm-hmm. In a big leap forward for zero-emission tech in aviation, a group of Dutch students from Aero Delft just nailed a world first, successfully testing a liquid hydrogen-powered electric propulsion system. The test happened at TNO research facilities in, I'm going to butcher this, I think it's Ypenburg, Ypenburg. Sorry, friends in Holland, and marks the debut of a flight-ready aircraft running on cryogenic hydrogen. Stand by, we'll explain. An incredible step toward cleaner skies, especially for long-distance flights. Ding, ding. That's so important, the long distance. Now, a little side note here. And this is what I do with the show notes, folks. We give highlights from each of the 4 articles, very high-level highlights. We give you the link so you can learn more if you want. But then I inject little tutorials because I go, cryogenic hydrogen? Wait a minute. I need help on this. So that's what the side note in this show notes does for you. So quickly, cryogenic hydrogen refers to hydrogen that has been cooled to extremely low temperatures, typically around minus 253 degrees Celsius, which would be minus 423 degrees Fahrenheit. Oh, that's cold. To become a liquid. Hang on to that, to become a liquid. So hydrogen cooled to the point where it becomes a liquid, all right? This process allows hydrogen to be stored and transported more efficiently compared to its gaseous form, as liquid hydrogen has a much higher energy density. These are all key points here. Cryogenic hydrogen, again, liquid hydrogen, is widely used in various industries, including aerospace, where it serves as a fuel for rockets, and in emerging clean energy technologies like hydrogen-powered vehicles. That's how it relates to this story. However, here's the problem, Ben. Storing and handling cryogenic hydrogen requires specialized equipment due to its extreme cold temperatures and flammability. So that's sort of the setup, Ben, for what we're going on here. And you and I both have covered the whole idea of hydrogen for aircraft in the past, but this is a different twist.
Yeah, it's hydrogen fuel for, well, rockets and space flight. Essentially, they somehow were able to. And I just want to say, they said a student team way at the beginning, were able to pull this off. And I got to say, Ralph, like, my high school engineering program back in like 9th grade, did the classic, egg drop test, up 2 or 3 flights of stairs, drop the egg. My school didn't like me using hair gel, because they were like, I was going to make a mess and whatever. These kids are messing with rocket fuel. And I'm like, our schools are not the same. What are they doing in Dutchland? That is, I don't know. It's crazy. It's crazy.
Doing some great stuff. And by the way, the show notes, if you're watching the video, you can see the very, very cool experimental aircraft these people have come up with too. It's very cool looking. Mm-hmm. So let's get into more about this, why this is so important. And there's a subhead in the article, why this test changes the game. So gaseous hydrogen has already made some waves in aviation. That's gaseous hydrogen, okay? But liquid hydrogen, that's the next level, the author stresses. It packs about 2.8 times the energy density of its gaseous cousin, meaning the liquid, which means longer flights without the not waiting in line, but weight as in heavy, without the weight headache you get with batteries. Wait a minute. Okay, I get it. So batteries on an aircraft present a weight problem. Yeah, hydrogen gives an alternative. Yeah, go ahead.
Yeah, it seems like they're saying that everything that goes into a hydrogen battery and a hydrogen fuel cell, including like the casing and all the other elements in there, this is just burning just the straight liquid. So it only gets lighter. It doesn't stay the same or even add that much weight overall. It doesn't add the weight problems. I would say even less than
exactly
the weight problems that you get with batteries.
Exactly right. And with regard to this, the author says that's a huge deal for electric planes that need to travel several hours and still stay light as in weight, in the sky. So that's why this is so important. So how does this work? This development, this system that the students, I should say, everyone's a kid to me because I'm so old. How does this work? The system keeps hydrogen super cold, minus 250 degrees Celsius kind of cold, instead of a specially designed inside a specially designed vacuum insulated cryogenic tank. This is what these students came up with, this specialized vacuum insulated cryogenic tank. Then, using an electrical heat exchanger, the fuel warms up just enough to feed a proton exchange membrane fuel cell safely and efficiently. And if you're a human being like me going, what? Proton exchange membrane fuel cell. I have inserted a detailed insert into the show notes to explain what that is. Very quickly, though, a proton exchange membrane fuel cell is a type of fuel cell that converts the chemical energy of hydrogen and oxygen into electricity through an electrochemical reaction. And again, if you want to geek out, come to the show notes. I've got all the information about what that is, okay? It's pretty interesting.
Mm-hmm.
And then, next subhead in the article, the author brings up hydrogen storage gets a major boost. This is the key development these students came up with. If you've ever wondered why hydrogen storage is such a hurdle in flight, it comes down to managing heat, stopping fuel boil off, and keeping the system structurally safe. And what the author says about what these students in Holland did, this test checked off all those boxes. The prototype didn't just survive those extreme conditions, it thrived, delivering a steady 75 kilowatts of power. That's enough to juice or power to fly a small 4-seat electric aircraft. That's what's shown in the picture in the show articles, or pardon me, the article show notes. Now, concluding, add in the unmatched energy density of liquid hydrogen, and suddenly we're looking at an actual path forward for practical, long-range, zero-emission aviation. So I kind of butchered this article a little bit here with stumbling around with my word fumbles, but please get the show notes, go out and read the whole article, check it out, because this is a significant step forward.
It's very impressive, very big. And of course, for the company, Aerodelft, that's, kind of putting this all together. I saw at the very end, because again, Ralph picks kind of the highlights and you can always get more information from the article itself.
Right.
And at the very end of the article, I kind of figured out, Ralph, why they've decided to include students in this. And they could see that, what they're going to do next is in 2025. So later this year, they're going to do a manned flight. So that's why they brought the students in.
Pretty cool.
Because they're pretty expendable. So you can just, throw a kid in there and launch it up and see what happens. It's, good use of students. It's
yes.
College students out there, do your internships. It's important.
Pretty cool.
Now, story number 1, very, very nice. Story number 2, though, we're going to go ahead and jump on down and let's talk about something that, Ralph, there was a video, I think, from Elon and his robot factory that I'm currently forgetting, of a robot dancing. There's more and more interest, Ralph, in this idea that robots are, and we talk about all the different kinds of forms, even on this show in particular, or, not this particular program, but like just on Computer America, Ralph, you've really highlighted and shown us a trend over time that robots are going to come in like, octopus tentacle form. They're going to come in inflatable rolly ball form. They're going to come in, so many different mannerisms. But now there's this big push to get human robots and humanoid robots, because, Ralph, like, our world is set up to be interfaced by people, and so if you can make a robot kind of match a person, it can suddenly do a lot more than, a robot designed to look like, I don't know, Wall-E or something. The push for human robotics is huge. It's happening everywhere. A lot of companies are trying for it, but you need, if robots are going to interact with the world like humans do, then they need to sense the world like humans do. And enter story number 2.
Yes. In fact, to set story 2 up a little bit more, been a key trend you and I've seen in the area of robotics and also prosthetics is artificial touch. The ability for a machine or for a prosthetic to sense touch. And this is a huge challenge, but there's been tremendous advances. And this story talks about a nice little twist that advances this further. It comes from Interesting Engineering. And the headline is Breakthrough Sensor Material Brings Human-Like Touch to Robots at Low Cost. And what you're going to find out is basically a very clever fix to a problem that this field has had up to this point. So here we go. Researchers from Northwestern University and Tel Aviv University, I love collaborations, discovered a flaw in widely used silicone rubber composites that was interfering with electrical sensing in robotic skin. That's another way of talking about artificial skin, robotic skin. The flaw was an ultra-thin insulating layer forming on the surface of conductive elastomer composites, which affected the accuracy of touch sensors, which affected the accuracy of touch sensors in robots. Now, talk about a simple solution, but a good discovery. By sanding down this layer, researchers improved electrical contact, making robotic skin more sensitive and precise in detecting shapes, curves, and edges. How about that, Ben? Just sanding it down.
Yeah, the flaw was an ultra thin insulating layer forming on the surface. So I guess like somewhere in the manufacturing, obviously you need to embed your circuits and stuff like that. No, it makes perfect sense. I'm surprised that they didn't catch that before, but
yeah, and it's a good example.
Researchers, so
yeah, and Ben, it's a good example of sometimes important discoveries are not exotic new material or way out there sort of stuff, but something simple like, wait a minute, dudes, if we just sand this down a little bit, maybe we can oh yeah, it works. So going on, they developed a calibration method to measure the thickness of this insulating layer, providing a new way to troubleshoot sensor performance. And to wrap this short little highlight, the study was published in Advanced Electronic Materials and calls for more rigorous testing standards in touch sensing and flexible electronics research. To wrap it all up, this could make robotic touch more human-like and accessible at lower cost. So we do have a link to the research paper and, of course, the original article. Check it out.
Yeah, and honestly, just something as simple as that, because if there is not a standard that they had to operate with, and research labs all over in the United States and other places in the world are working on this problem, and no one's ever said this is a problem that you need to look out for. Hey, this could advance the research altogether. So
yeah, agree.
It seems like a small thing, but it can actually be a very, very good thing. So story number 2, story number 3, we're going to go ahead and talk a little bit about a new fiber optic technology. And we all, I think, enjoy our fast internet and our readily access, our ready access to data. Let's talk about maybe making that a little bit better.
Yeah. This is, now I'm going to forewarn everyone, this is pretty geeky stuff, and we are going to spend some quality time on this because it needs an explanation, but it's very cool. This comes from techradar.com. Headline: Glass out, plastic in. New fiber optic technology set to be deployed in AI data centers is both cheaper and faster. So this technology is a big breakthrough. The implication is that this would be most attractive initially to large data centers. And Ben, from previous shows, I live really close to, I don't know how many data centers we have in Hillsboro, Oregon, which is also the home of the most advanced research for Intel Corporation. But anyway, with that said, the focus here is new fiber optic technology, most likely to be deployed in AI-related data centers, being cheaper and faster. That's the key. So let's get into this. This article reports on a breakthrough plastic optical fiber technology, developed by researchers at the Keio University in Japan. That's Keio. I hope I'm pronouncing that correctly. Now, this new multi-core, okay, it's going to get geeky. This new multi-core graded index plastic optical fiber can transmit data at speeds of up to 106.25 gigabits per second per core, making it especially attractive for AI data centers where short-range, high-speed communications between GPUs and accelerators are critical. Okay? Now, here's where I added value, I hope, to the article. I said, well, wait a minute, don't assume that I know what graded index plastic optical fiber, and multi-core, what are they talking about? Very quickly, because you can read more in the show notes. A graded index refers to a type of optical fiber where the refractive index of the core gradually decreases as you move away from the center. Oh yeah, now I totally get it. I'm just kidding. Another side note, and regarding the comment about speeds of up to 106 0.25 gigabits per core. In this context, the core refers to the central part of the optical fiber where light signals travel. Now, I know this is like, what? It's pretty geeky.
Yeah. It is, but it's also, one of those fundamental parts of a data center that they're making, much more
better,
cost effective and
yes, well,
really
cost effective. Yeah, you're right. Going from glass to plastic, you can imagine this is a big, big change. Instead of using traditional glass, the researchers have turned to plastic, which enables a simplified, single-step extrusion molding process to produce the fibers. Wow. And this manufacturing method not only cuts production costs by a factor of 10 to 100 compared to conventional glass fiber techniques, but it also reduces the complexity typically associated with ribbonizing and connecting multiple glass fibers. I warned you at the front, this is geeky. You have to be a fiber optics geek to really love this story. And then, remarkably, the bit error rates were reduced by between 10,000 to 100,000 fold relative to traditional glass systems. What? It's cheaper, easier to make, and whoa, reduction of bit error rates at that range?
Yeah.
Wow.
It almost seems too good to be true, but I'm sure, changing your manufacturing process is a hurdle in itself, but it needs to be all those things. It needs to be cheaper, better, and more accurate. So
there it is. Yeah, it's kind of like a win-win-win-win-win. And wrapping this up here, beyond its immediate application in AI data centers, that's where they think it's going to be most attractive initially, this breakthrough hints at a larger shift in data transmission technologies. With steep cost reductions, simplified manufacturing, and enhanced performance, plastic optical fibers might soon play a crucial role in revolutionizing high-speed communications across various sectors. So once again, a very important technology and science advancement, this time coming from Japan. So salute to our friends in Japan for that one.
And I know that they had to tick off a couple of, SEO, AI, data center, kind of tick boxes. But my immediate thought is, more and more, especially in the United States, more and more municipalities are installing fiber optic to finally replace old DSL and copper lines to people's homes. And, Ralph, like, hey, if this is a better, faster, cheaper alternative and does the job even better, hey, maybe we can roll out high-speed internet to more and more rural areas. That would be, ideal. So
yeah, you're right.
So there you go. So now story number 3, very cool. Good job, Japan. Story number 4. Let's go ahead and talk about rice, but rather things that are rice size. And when it comes to miniaturization of not just robotics, and obviously the term robot is very, very loose, but just the miniaturization of like technology and medical technology, in particular implants and injectables and things like that, Ralph, that's really hit a stride in the past couple of years. Like a lot of the research has shown that, hey, we can miniaturize these products. Story number 4, as you always like to say, is focus on medical technology.
Yep.
He always focuses on that. And story number 4 is amazing for people who maybe have a tumor in the brain. So
Yes. And Ben, you did a good job in kind of framing the trends that we've been looking at in the world of medical technology science. Robotics, of course, plays a huge role in all kinds of ways. But one of the things that's been so interesting for Ben and me over the past couple of years is miniaturization of devices that can be guided into the body. Tiny things, that sensors, probes, items that can dispense medication or chemotherapy and this sort of thing, robotically controlled. And sometimes robotically controlled just means using magnets and so forth to move the item through the body where the doctors want it to be, and so on and so forth. This is in that family of trends, let's call it that. This story comes from Interesting Engineering, one of my favorite outlets. Headline: New rice-sized microbot could slip into brain to treat inoperable tumors. And Really, folks, if you're looking at the video, you can see the picture of the person, their fingers outstretched, and you can see this tiny, tiny micro robot. And there's a close-up of that item as well in the show notes. So check that out. There's a YouTube video you can look at as well. Really cool stuff. So let's get into this. The article describes a revolutionary neurosurgical micro robot, roughly the size of a grain of rice, designed to navigate the brain with unmatched precision. Developed by a French startup, the company's called Robote. I hope I'm saying that right. The device moves at a gentle pace of about 3 millimeters per minute, so very slow, utilizing rotating silicon rings to delicately part brain tissue without damaging cells. Wow. That's something.
Sorry, but just realize that, when it comes to, I guess, brain surgery, you don't really have a lot of space or room to just cut it open a little bit more, just, kind of spread that out.
Exactly.
And just very, very tight spaces. So makes sense.
It is. This is such a breakthrough. This innovative technique promises to offer a far less invasive way to perform procedures like microbiopsies on brain tumors, potentially transforming the treatment of cases deemed inoperable with traditional rigid surgical tools. This point we're going to emphasize. Traditional brain surgery often relies on instruments that move in straight lines, such as needles or electrode holders, which can limit a surgeon's ability to avoid critical regions responsible for motor and cognitive functions. That's the problem. Now, here comes the solution. Instead, this microbot can meander through the complex structure of the brain safely, providing accurate information and access to areas that were previously hard to reach. If this doesn't leave you feeling good at the end of the week, I give up.
Good with the implications, but I was just thinking, do you think you could feel it move in there, or do you think that's probably not? Probably not. But
let's hope not. Anyway, you're probably sedated anyway when they're doing this to you, so it's probably no problem. So here's the deal: clinical trials are slated to begin in 2026, next year, of course, marking this breakthrough as a crucial step towards safer and more precise neurosurgical interventions. Oh my gosh, so great. Beyond its immediate application in tumor diagnosis and therapy, this microbot represents a broader shift in medical robotics toward minimal invasiveness and enhanced precision. Great sentence, because again, this whole trend for miniaturization, for minimal invasiveness is something you and I, Ben, have seen time and time again. And to wrap this up, this innovation not only paves the way for future robotic-assisted procedures, but also invites further exploration into other delicate operations where precision is paramount. I can't think of a better way to leave us all feeling better. That's what we do every Friday, by the way. We want to leave you feeling good about the world, as opposed to all other news outlets that are just doom and gloom.
No, this is far from doom and gloom, and they didn't include it in the article, but I'm sure at the end it just falls out your ear and you're good to go. The least invasive. No,
yes.
It is really an amazing device, and be able to deliver that very precise I'm sure payload of medicine, or bring out the sample that they need to take a test with. Amazing, and really amazing robotics and stuff. And check out the video. You can find that at computeramerica.com. Go to the show notes, go to the Ralph Bond section, and you can find our latest program right there, as well as all podcast and YouTube and social media, all that good stuff. Ralph, that was an amazing 4 stories that you rounded up for us. And for those out there who are following along, because by the time that you hear this, the show notes are available, you may notice there are even more show notes. There are even more stories. We felt so bad that at the end of the day, people were like, Ben, it's crazy. You can only do half an hour of good news a week. The rest of it's just so dour. No, there's more good news out there. It's just for your listening enjoyment, we try to shorten it just a little bit. And that's, Ralph, where we come in with the honorable mentions, stories that you should check out, but we don't have time for on the program itself. So let's at least give the nice folks the headlines, and we can have them come out to the show notes and check it out themselves.
You got it. You got it, Ben. So we have 4 honorable mentions, which we usually do every week. The first one comes from The Hearing Review. Very interesting, very focused publication. Headline: Soft Auditory Brainstem Implant to improve upon hard auditory brainstem implant. So this is a new soft version of what's already been out there, but in the form of a hard implant, right? So check that story out. That's another medical science technology advancement. The next one comes from an outlet online called Techno Science. Headline: 3D printing with sunlight. Very interesting. Check that one out. Our next one is from the Carnegie Mellon University news outlet. Headline: Researchers develop microelectronics for space and aerospace applications. So it's an advancement in durability and so forth for the extremely harsh environments of outer space, of course. And the last one, our 4th honorable mention, also from Interesting Engineering, and this is NASA related. So Nighthawk, NASA plans massive Mars helicopter to scan ancient volcanoes for life. Check it out. This is another advancement in drones for Mars.
Yeah, always a fan of what NASA's been up to,
yes,
and what they're doing in the doing in the near term. Because hey, hopefully in the next couple of years we start hearing more and more about these projects of going back to the moon, making some kind of permanent settlement on the moon.
Yeah,
and hey, maybe even in the not too distant future, missions to Mars. That's on the horizon. So with that being said, Ralph, the music is playing in the background, but I want to thank you so much for coming on the program. And ladies and gentlemen, if you want to hear more from Ralph, hey, check out our website, check out the Ralph Bond section right there at the top, and it'll have everything right there. So with that being said, ladies and gentlemen, thank you for tuning into Computer America. We appreciate it so much that you listen. And hey, catch us here next time with Ralph every Friday. And yeah, ladies and gentlemen, have a good weekend. Do something fun. We'll catch you next week. Be good. Bye, everyone.